Water, the lifeblood of our planet, is in constant motion. It flows through rivers, streams, and oceans, creating a dynamic and ever-changing landscape. This continuous movement of water, from the vast oceans to the atmosphere, to the land and back again, is called the hydrologic cycle. It involves several key processes, including evaporation, condensation, precipitation, and collection. This natural process is essential for all life on Earth. It supports lush forests, vibrant coral reefs, and diverse wildlife, providing the necessary hydration for plants and animals to thrive. The water cycle is driven by the sun's energy and the force of gravity. The sun heats up water in rivers, lakes, and oceans, causing it to evaporate and rise into the atmosphere. Gravity then pulls the water back down to Earth in the form of precipitation. It is a closed system, meaning that no water is lost or gained during the process. The same water molecules have been cycling through the system for millions of years, constantly being recycled and reused. Instead, water is constantly being recycled. Rainwater is absorbed by the soil, replenishing groundwater supplies, and eventually making its way back to rivers and lakes, continuing the cycle. Understanding the hydrologic cycle is crucial for managing water resources, predicting weather patterns, and comprehending the delicate balance of our planet's ecosystems. By studying this cycle, scientists and meteorologists can better forecast weather, manage water supplies, and protect natural habitats. The journey of water begins with evaporation. This is the process where liquid water transforms into water vapor, an invisible gas. The sun's energy provides the heat needed for this transformation. As the sun warms the Earth's surface, water from oceans, lakes, rivers, and even the soil evaporates into the atmosphere. Vast amounts of water evaporate from the oceans, which act as immense reservoirs. Transpiration, the process of water vapor being released from plants, also contributes to the water vapor in the atmosphere. As water vapor rises into the atmosphere, it encounters cooler temperatures. This journey begins from various sources such as oceans, rivers, and even plants through a process called transpiration. The sun's heat causes water to evaporate, turning it into vapor that ascends into the sky. This cooling causes the water vapor to condense back into tiny water droplets or ice crystals. These droplets are so small that they remain suspended in the air, forming the basis of cloud formation. The process is similar to how dew forms on grass in the early morning. These droplets and crystals then clump together, forming clouds. Over time, these clouds can grow larger and denser, depending on the amount of water vapor available and the atmospheric conditions. The process of condensation is essential for cloud formation and is a vital stage in the water cycle. Without condensation, there would be no clouds, and consequently, no precipitation to replenish our water sources. The type of cloud formed depends on the temperature and the amount of water vapor present. For instance, high-altitude clouds like cirrus are formed from ice crystals due to the colder temperatures up there. Cumulus clouds, for example, are fluffy and white, often associated with fair weather. They form when warm air rises and cools, causing the water vapor to condense into visible cloud droplets. On the other hand, dark, towering cumulonimbus clouds often bring thunderstorms. These clouds can reach great heights and are capable of producing severe weather, including heavy rain, lightning, and even tornadoes. Understanding the process of condensation helps us predict weather patterns and prepare for various atmospheric conditions. As water droplets or ice crystals in clouds grow larger and heavier, they undergo a fascinating transformation. Eventually, these droplets or crystals become too heavy to remain suspended in the air and fall back to Earth as precipitation. Precipitation takes various forms, including rain, which nourishes our landscapes and fills our lakes and rivers. Snow, which blankets the ground in a serene white layer. Sleet, a mix of rain and snow that can make roads slippery. And hail, which are large ice pellets that can cause significant damage. The type of precipitation that falls depends on the temperature of the atmosphere through which the water travels. Warm air can hold more moisture, leading to rain, while colder air results in snow or sleet. Rain is the most common form of precipitation and is essential for life on Earth, providing the water needed for plants, animals, and humans. Snow occurs when temperatures are below freezing, causing the water vapor in the air to freeze into ice crystals, which then fall to the ground, creating beautiful winter landscapes. Sleet is a mixture of rain and snow, often seen during transitional weather when temperatures fluctuate around the freezing point. Hail consists of large ice pellets formed in thunderstorms, created when updrafts in the storm carry raindrops upward into extremely cold areas of the atmosphere. where they freeze and grow larger before falling to the ground. Section 5. Water cycle's influence on climate. The hydrologic cycle plays a crucial role in regulating Earth's climate. Evaporation helps to cool the planet's surface by transferring heat from the Earth to the atmosphere. Condensation, on the other hand, releases heat into the atmosphere, contributing to weather patterns. The distribution of precipitation across the globe is also influenced by the water cycle. Areas near large bodies of water, like oceans, tend to experience more precipitation due to higher evaporation rates. Conversely, inland regions often receive less rainfall. Section 6. Shaping ecosystems with water. The water cycle is fundamental to the health and diversity of Earth's ecosystems. Water availability shapes the types of plants and animals that can thrive in a particular region. From lush rainforests to arid deserts, each ecosystem has adapted to its unique water cycle patterns. Rivers and streams, fed by precipitation and groundwater, carve out landscapes and create habitats for a variety of aquatic species. Wetlands, acting like natural sponges, filter pollutants and provide breeding grounds for many creatures. Section 7. Water availability and ecosystem stability. The balance of water within an ecosystem is crucial for its stability. Too much water can lead to flooding and erosion, while too little can result in drought and desertification. Ecosystems thrive when there is a reliable and consistent supply of water to support their inhabitants. Changes in precipitation patterns, often linked to climate change, can disrupt this delicate balance. Prolonged droughts can lead to water shortages, impacting both wildlife and human populations that rely on these precious resources. Section 8. Human impact and future challenges. Human activities, such as deforestation, urbanization, and agriculture, can significantly impact the water cycle. Deforestation reduces transpiration, affecting local rainfall patterns. Urbanization increases runoff, leading to flooding and water pollution. Over-extraction of groundwater for irrigation can deplete aquifers faster than they can naturally recharge. Understanding these impacts is crucial for developing sustainable water management practices. Section 9. Conclusion: a precious cycle for life. The hydrologic cycle is a fundamental process that sustains life on Earth. From the smallest microorganisms to the largest mammals, all living organisms depend on the continuous circulation of water. As we face the challenges of a changing climate, understanding and protecting this vital cycle is more critical than ever. By conserving water, reducing pollution, and promoting sustainable practices, we can help ensure the continuity of this precious cycle for generations to come.